Greatest common factor is the greatest number that divides into two or more numbers. So if we're looking at two numbers written in exponential form, like 2 cubed and 2 squared, we can think about what they actually mean. In this case, 8 and 4. And what we're asking ourselves is, what is the largest number that will go into or divide into both of those numbers? In this example, 4 would be the GCF because that's the biggest number that will go into both. But let's think about it without looking at what these numbers equal. Let's think about it just by looking at the prime factorization of each. So now when we look at the prime factorization of each, 2 cubed and 2 squared, that's two different numbers written in exponential form using the prime numbers. So what we're going to ask ourselves is, will 2 squared divide into 2 cubed? Or will 2 cubed divide into 2 squared? Well, hopefully you figured out that 2 squared will divide into 2 cubed. 4 will divide into 8. So that's the greatest common factor. If we were to write this as exponential form, the greatest common factor would be 2 squared. So let's look at some harder examples. We're going to come down here and look at 12 and 15. We're looking for the greatest number that divides into both 12 and 15. So we're going to break these numbers into their prime numbers and write them using exponential form as shown. Now what we're going to do is compare the same bases. And by bases, what I mean are these numbers that are being raised to exponents. Those are called bases. So we're going to compare the ones that are the same. Well, the only bases they have that are the same are the 3's. So this is going to be the greatest common factor of 12 and 15. Because it's the only number they have in common that will divide into both of these numbers. So let's look at some more examples. Suppose the numbers we're working with are completely broken down into exponential form as you see here. We have number 1 here and number 2 here. These are two completely different numbers. If we wanted to, we could multiply to see what they equaled, but that wouldn't really help us in finding the GCF. So what we're going to do is figure out which one will go into which. So will 2 squared divide into 2 to the 4th, or will 2 to the 4th divide into 2 squared? Well, if you said 2 to the squared would divide into 2 to the 4th, you're right. So when we start figuring out the GCF, the first thing we're going to put is 2 to the 2nd power. So what we're doing is we are comparing same bases. So we're comparing 2 to the 2nd to 2 to the 4th. And whichever one is the smaller, it will divide into the bigger. So that's our greatest common factor for that base. So now let's look at 3 to the 5th and 3 squared. Which one do you think would divide into the other? Well, 3 to the squared will divide into 3 to the 5th. So now we continue on and we compare our 5's, but we don't have a 5 in both of our numbers. So since we don't have that base in common, 5 will not go into our second number. There's nowhere to divide it into. There's no number down here that's divisible by 5. 7 times 7 is not going to be divisible by 5. 3 times 3, which is 9, is not divisible by 5. And 2 to the 4th, which is 16, is not divisible by 5 because none of those have 5s as part of their makeup. So 5 doesn't even count because the two numbers don't have it in common as a factor. Same thing with 7 cubed. The two numbers do not have a 7 in common anywhere, so we don't use that as part of the common factor. So what we end up with then is 2 squared times 3 squared, which would be the greatest common factor in exponential form. So let's think this through another way. So if we're looking at these two numbers here, 2 squared is going to divide into both 2 to the 4th and 2 to the 2nd power. And we need it to be able to divide into both of those if it's the greatest common factor. And then 3 squared is going to divide into 3 squared and into which it needs to be able to divide into each of those in order for it to be a common factor. So what we're doing here is we are breaking our numbers down into common factors and comparing the factors instead of the whole entire numbers themselves, which makes it a lot easier to deal with big numbers. Now let's talk about the least common multiple. The least common multiple is the smallest number that both numbers will divide into. So let's again look at 2 cubed and 2 squared. Again, you can think about these as equaling 8 and 4. Which one of those will both of them divide into? Well, 2 squared will go into 8 and 8 will go into 8, or 4 will go into 8 and 8 will go into 8. So you're asking yourself, will 2 squared divide into 2 cubed? And then will 2 cubed divide into itself? Yes. Okay. So the least common multiple, multiples are usually the larger numbers, right? So it's usually going to be your larger exponent. So in this case, 2 cubed is going to be your LCM between 2 cubed and 2 squared. Or if you were thinking about it as numbers, you could think about it as 8 and 4. So this is 8 and this is 4. The least common multiple would be 8 because 8 goes into 8 and 4 goes into 8. All right, so let's look at these examples that we were talking about for GCF. So let's say we have 12, which is 2 squared times 3, and 15, which is 3 times 5. Well, we're going to compare what these have in common. So first we have 2 squared. They don't have 2 squared in common, so 2 squared is going to have to be part of the least common multiple because you want 2 squared to be able to divide into your final answer, right? Because both numbers have to be able to divide in. And then we have this 3 that they both have in common. Well, we only need to write it once in order for the 3 and the 12 to divide into it, and for the 3 to the 15 and that's in the 15 to divide into it. So in order for that particular prime number, the number 3, to divide into the least common multiple, we only need to write it once, since there's only one 3 in the 12 and one 3 in the 15. Then, all right, we have already included the 2 squared here and the 3 here and the 3 here, so all we have left is the 5, so we need to include the 5. Basically, we need to include all the factors of each of the numbers without double counting anything. So if I see the 3 however many times in the 12, if it's the same number of times in the 15, I don't count it again for the 15. So this becomes my least common multiple. Let's look at another example. So here's the other example we were working with. So this time we're going to ask ourselves when we're comparing the bases, which number will divide into the other. Basically, we want the bigger one. So 2 squared will go into 2 to the 4th. So 2 to the 4th is what we will write down for our base of 2. And then for our base of 3, 3 squared will go into 3 to the 5th. So 3 to the 5th is going to be what we use for our base of 3. And then we have this 5 that is not in the other number, but we have to include it or else that first number will not divide into it. And then we have this 7 cubed that we have to include for the other number, because if we don't, then that second number won't be able to divide into this. So this is our final answer. So one way to think about this is you write down all your bases that you see. We see a 2, a 3, a 5, and a 7. And then you include the highest exponent on each. Here we included the 4, here we included the 5. We had to include the 5, and we had to include the 7 to the 3rd. Because you always want to include all your bases. So our goal here is to make sure that every part of our numbers will be able to divide into our least common multiple. So the way you're thinking about it is, will 2 squared divide into 2 to the 4th? Yep. Will 2 to the 4th divide into 2 to the 4th? Yep. Will 3 to the 5th divide into 3 to the 5th? Yes, it will. Will 3 squared divide into 3 to the 5th? Yes. Will 5 divide into 5? Yes, it will. Will 7 cubed divide into 7 cubed? So when you're finding the least common multiple, you're making sure that every single prime number and its exponent can divide into each of the prime numbers with their exponent for the least common multiple. Whereas with the greatest common factor, you're making sure that the greatest common factors divide back up into the numbers themselves. Let's look at an example here. We have two different numbers and we want to find the GCF and LCM. So for the GCF, we want to find what they have in common. So the base of 2 they have in common. The base of 3 they have in common. The base of 5 they have in common. The 11 and 7 they do not have in common. So now we're trying to figure out what exponent to use so it will divide into these. Well, 2 to the first will divide into 2 to the first, and 2 will divide into 2 cubed. So we don't want to put 2 cubed because if we put 2 cubed, that would not divide up here into the 2. That wouldn't work. So we're going to go with that lowest exponent. So that's the goal, go with your lowest exponent of what they have in common. So what about 3 squared and 3 to the 4th? What do you think? Should be 3 squared, right? Because 3 squared will divide into 3 to the 4th, and it will divide into 3 squared. Now, how about the 5? Should be 5 squared, right? Because 5 squared will divide into 5 squared, and it will divide into 5 to the 3rd. We don't want the 11 or 7 because the 11 is not going to divide into both numbers since the second number doesn't have an 11. And then the 7 won't divide into that first number because that first number doesn't have a 7 as part of its makeup. So it won't divide into it. So that's our GCF. All right, so our LCM. So instead, with GCF, we were dividing up into these numbers. Well, with LCM, it's the other way around. We're dividing these down into whatever our LCM is. So we want to go with the largest exponent on anything they have in common, but also include anything they don't have in common. So let's start with our bases. So we have bases of 2, 3, 5, 7, and 11. Doesn't matter if they have them in common for LCM because we need both numbers to divide into it. Okay, we're going to go with the highest exponent because this time we're dividing down. So 2 cubed will divide into 2 cubed, and 2 will divide into 2 cubed. So that works. So what about the 3? So for the 3, we're going to have the highest exponent of 4. So we double check. 3 to the 4th will go into 3 to the 4th, and 3 squared will go into 3 to the 4th. And then 5, we should use an exponent of 3. That's the highest exponent. That way we know 5 squared will divide into it, and 5 cubed will divide into it. And then we have to include our 7 and our 11. The 7 to make sure that the second number will divide into this, and then the 11 to make sure that that first number can divide into this. And this gives us the least common multiple. So the rule of thumb is, for the least common multiple, we're going to want all bases written once with the highest exponent on each. And you include all the bases, even if they don't have, the two numbers don't have that base in common. And the greatest common factor, you want to include only the bases the numbers have in common and the lowest exponent on each.